to a system in excess of 50 milligrams per liter. When grease traps are required, the effluent from the grease trap shall be deposited into the septic tank and not directly into an absorption field. Beginning at the house, all solid pipe fittings shall be Schedule 40 PVC or equivalent and shall be a minimum of 4 inches in diameter. All septic tank openings must be sealed and watertight. The next component of an individual on-site sewage management system consists of septic drain field absorption lines, or trenches. There are several different types of absorption field lines available. Let's start with the aggregate system. That is a system that uses gravel or other approved aggregate material. An aggregate or gravel system must be installed in accordance with the following minimum design and construction criteria. The aggregate itself shall be 1/2 to 2 inches in diameter and pre-washed. Absorption lines and trench bottoms shall be true to grade, that is, level for their entire length. Trench bottom depth shall be based on what is indicated on the permit. Absorption trenches shall be no more than 36 inches wide and spaced a minimum of 8 feet apart, center to center. On average, 15 tons of gravel aggregate per 100 linear feet of absorption field at a width of 36 inches will be needed to maintain a 12-inch depth throughout the system. The minimum depth of aggregate shall be 12 inches with 6 inches below the perforated pipe and filled to 2 inches above the pipe. Perforated pipe shall be laid in the center of the trench with the perforations oriented toward the bottom of the trench. A layer of pervious building paper, straw, or similar permeable material approved by the department's technical review committee shall be placed over the aggregate before backfilling. A minimum of 6 inches to 12 inches of earth cover is required over absorption lines. The maximum earth cover shall not be greater than 24 inches unless special conditions are noted on the permit. Schedule 40 PVC or equivalent solid pipe and fittings with sealed, watertight joints shall be used for horizontal and vertical changes in direction or grade and to cross under roadways or paved areas. Sections of solid pipe shall not be considered in determining the total absorption trench bottom area. Excavation for absorption trenches in soil other than sands should not be conducted when wet due to the potential irreversible damage to soil structure, such as compaction and smearing. An aggregate gravel system may be installed in 3 standard configurations. These configurations are the level field system, serial system, and the distribution box system. On level or sloping topography of 5% or less, the level field method may be used. When this method is used, the absorption field shall be installed level with all absorption lines interconnected to form a continuous system. A standard T-fitting or approved distribution device shall be used to interconnect the absorption lines. On sloping topography, the serial distribution method may be used. When this method is used, level absorption trenches shall be constructed parallel along the ground contours. The sewer from the septic tank shall enter the uppermost absorption line or trench and connect at any point in the line, so all effluent from the septic tank is discharged into the first absorption line. It is important that the overflow sewer between the first and second trench be a minimum of 4 inches below the septic tank outlet. This is necessary to prevent effluent from flowing back into the septic tank when the first absorption trench fills to capacity prior to overflowing into the second trench.
Okay, what we're doing here is establishing the grade of the spillover between the 2 ditches being constructed. We're looking at that spillover to be approximately 1 to 3 inches above the gravel level. of the lines. Setting the height of the spillover pipe in the serial system. The important thing here is to try to keep this spillover set, the pipe overflow pipe at about 13 to 14 inches from the base of the trench to allow the water to fill up in the first ditch before going to the second. What we have here is an area of undisturbed earth set at approximately 14 inches. What we want that pipe to do is to come up and over and rest on this undisturbed earth. And that's the most important part of the serial system, is to make certain that we do not dig through the spillovers, that we leave this as natural ground so we can prevent the bleeding from one trench to the other in this area. It's important for the contractor to ensure that the ditches, the elevation of the spillover is not above the outlet of the tank. You must have at least 4 inches difference between the top of the spillover and the outlet of the septic tank to ensure that the water cannot back up into the system prior to overflowing to the second ditch. The best way to check this is to shoot the top of the overflow spillover at the highest point and then shoot the outlet into the tank to ensure that there's at least 4 inches lower on the top of the spillover pipe than the outlet into the tank.
On level or sloping topography, the distribution box method may be used. The distribution box must be set on a level concrete pad as a foundation or on undisturbed earth. If set on soil, the box must have concrete poured at its base, extending at least 12 inches beyond the walls of the box to ensure against tilting. Installation of the distribution box shall be made to provide the equal flow to each absorption line extending from the box. This is done by making sure the box is absolutely level. The best method of leveling a distribution box is by filling it with water. The top of the distribution box shall have a minimum earth cover of 6 inches, but no more than 12 inches unless provisions are made for easy access to the distribution box. The sewer pipe from the septic tank shall enter the distribution box and terminate inside the distribution box with an elbow turned downward to form a submerged discharge of the effluent below normal water level. Absorption lines of equal length shall be connected to distribution box outlets by watertight independent sewers consisting of 4-inch Schedule 40 PVC pipe or equivalent. Each absorption line extending from a distribution box system shall not exceed 125 feet in length. All independent sewer pipes coming out of the distribution box shall be installed level at the same elevation for 2 feet. Beginning 2 feet from the distribution box to the beginning of the perforated pipe at the start of each absorption trench, a minimum of 2 inches downward grade is required. Absorption trenches for a distribution box system can be installed level on a uniform change in grade of no more than 4 inches of fall per 100 feet. This is the only exception to the absorption trench leveling requirement. The department's technical review committee may approve other distribution devices for use with conventional septic tank systems. The chamber system is another septic tank absorption line option that may be used instead of aggregate or gravel systems. Trench excavation and spillover or overflow pipe construction is similar to that of the aggregate system. However, these systems do not require the use of aggregate. Chamber system means a system using chambers of molded polyolefin plastic. The plastic is shaped to form a hollow structure with an exposed bottom area for infiltration of effluent into adjoining bottom and sidewall soil areas. Chambers may be of different sizes and configurations to obtain desired surface area. However, on average, each panel is 6 feet, 3 inches in length. Reduction in absorption field size may be given for chamber systems. However, reduction should not be automatically assumed, and you should check with the department for specific information. Chamber leaching systems provide flexibility and may be adapted to most design situations. Installation instructions for various chambers will be based on specific manufacturer's recommendations, which have been reviewed and approved. All chamber systems must be installed in accordance with the following minimum standards. All chambers shall be designed and constructed to support vertical uniform loading of 600 pounds per square feet on the top of the chamber without damage or permanent deformation. All chambers shall be designed and constructed to provide ports, slots, or other similar openings on sidewalls to allow air movement and effluent access to lateral field trench sidewall absorption surfaces. All chambers shall be designed and constructed to be interlocking to allow continuous installation of chambers and be provided with acceptable end plates, caps, or other necessary fittings and connectors. All chambers shall be designed to accommodate at least one inspection port of a minimum internal dimension of 4 inches centrally located in the top of the chamber. All such chambers offered for sale or use in Georgia shall bear an imprint, a stencil, or other acceptable means of permanent marking of the manufacturer's name and the number assigned by the department to the manufacturer's plans and specifications. The plans and specifications are approved by the department. This imprint, stencil, or other marking shall be located beside the observation port. Only high-capacity designs shall be used. Metal chamber systems are prohibited. When backfilling a chamber system absorption line, you should fill the sidewall areas first and pack down the fill by walking along the edges of the chamber units prior to placing soil over the top of the chambers. Large diameter gravelless pipe may also be used in drain field installations. This pipe may commonly be referred to as sock pipe. The basic design principles in spillover construction are similar to that of the aggregate and chamber systems. A painted or other clearly marked line shall be placed on each section to denote the top of the pipe. Tire chip and styrofoam aggregate may also be used in absorption trench installations. Tire chip aggregate should be installed based on conventional septic system criteria and absorption field line methods. When installing a styrofoam aggregate system, the protective sleeve to hold the aggregate in place must not be cut. It can only be installed in units of 10 feet in length and must comply with department standards. If gravity flow is not possible to access the desired absorption field location for any type of system, an effluent pumping system may be required. Pumps used in on-site sewage management must meet the following requirements. Pumps must be submersible and wastewater approved. The pump must be capable of delivering the required flow at the designed total dynamic head. When pumps are used, they cannot be placed inside the primary septic tank. Pumps are to be placed in a separate pumping chamber. All wiring and components of the pumping system shall conform to the National Electrical Code. When pumping chambers are required, specific installation instructions will be noted on the permit. These type systems may require additional instruction, and you should work closely with the inspector when installing these systems. The use of aerobic treatment units may also be required in special situations. Aerobic treatment units must meet the following requirements. All aerobic treatment units must be approved for use by the department's technical review committee. The units must meet the testing criteria and performance levels specified by ANSI NSF Standard Number 40 for residential wastewater treatment systems and must be installed by an authorized representative of the manufacturer. These type installations require special instruction and may require additional site evaluations. The local health department can provide additional information about these units. In addition to the installations requiring special conditions, you should be aware that all sewage system additives which are used to enhance the operation of an on-site sewage management system must be approved by the department. Upon completion of the system, the environmental health section of the health department must be contacted for a final inspection. As a licensed contractor, you should be aware that no person may cover or use an on-site sewage management system until final inspection has been made and written approval has been issued. Failure to comply with this regulation or any septic system management regulation will result in decertification. In addition to decertification, you should be aware that it is a misdemeanor to cover or use a septic tank system prior to receiving a final inspection and approval from the health department. Inspection times for final approval of a completed septic system will vary from county to county. You should contact your local environmental health section for available times for inspections. When the system installation has been completed, you should have a copy of the permit in hand in order to supply the necessary information, which may include the permit number and time the inspection is needed, the subdivision name, lot number, street or road name, the installer's name, the property owner's name, a phone number where you can be reached. If you realize that you will not be ready for inspection at the time requested, you should contact the health department to prevent an unnecessary site visit. This courtesy will help the inspector make the best use of time and ensure inspections are conducted as close to requested times as possible. At the time of final inspection, approval or denial will be issued by the inspector. After receiving final approval, the system can be backfilled. The backfill material should not contain large stones, stumps, broken masonry, or other such materials which may adversely affect the functioning of the system. Records of sewage system installations are maintained at the local environmental health office and may be obtained upon request. As a licensed contractor, you will be required to be recertified every 2 years. Your ability to be recertified is based on your continuing education in waste management systems. Because of many factors, including its pristine environment, the state of Georgia enjoys one of the highest growth rates of any state in the Southeast and one of the highest growth rates of all the states in the country. Each year, more than 30,000 new on-site sewage systems are installed in Georgia. This number, added to the more than 600,000 existing on-site sewage system, yields more than 75 million gallons of wastewater being discharged into the soils of our state each day. Now, more than ever before, our natural resources are in a precarious state. We must all do our jobs well to ensure that our home environment is safe for our families and the families of the future. As on-site sewage contractors, you play a vital role in a partnership that will ensure our state will be a healthy place to live and work for generations to come. The regulations presented on this video are our game plan. The public health inspectors are our coaches, and together we will form the team that will make this partnership successful.